Okay, we're going to start looking at the whole process of solving. This is section 1.5 and 1.6 notes. We're going to see problems today that have the possibility of using all the solving steps. Remember, the solving steps are distributive property and combined like terms. After that point, that's when we start looking at both sides of the equal sign. So I'm going to draw a line right here, and we start using opposite operations and working on both sides of the equal sign. And then we're also going to talk about how to check to make sure our answer is correct. So that is the checking part. So let's go through this one and see if we need to use all these boxes. So this problem has parentheses, so we do need to use distribution to get them out of here. So that gives 2x, and 2 times negative 6 is negative 12. And you've got 9x plus 2. Then in this particular one, when we look for like terms, they must be on the same side of the equal sign, and I have no like terms, so that box we get to skip. All right, so then we take the equation down to this box because I have letters on both sides. It is always best, it is a good idea to take care of your letters first. It usually makes the solving process go more smoothly if you worry about getting all those letters together first. Here, remember, you can either do the left or the right side. I'm going to subtract the 2x to make the positive 2x disappear and get 7x plus 2. So notice here that I started doing things to both sides of the equal sign once I passed over that line. So now we take that equation, negative 12 equals 7x plus 2. We're going to clear the constant, which is the 2 in this problem, by minusing or subtracting 2 from both sides. Again, I'm doing opposite operations to both sides because I'm beyond that line. Here I get 7x equals negative 14. Careful with arithmetic right there. And then I'm going to clear the coefficient. Negative 14 equals 7x. I'm going to divide both sides to get rid of the multiplication. X equals negative 2. So now, if I want to check that, I go back to my original problem, and I saw that 2 parentheses x minus 6, and the other side is 9x plus 2. So I'm going to plug in the number that I think is the solution here. So 2, and then negative 2 minus 6. So that's parentheses here. I'm doing the order of operations. This is 2 times negative 8. So this side gets me negative 16. And then I try it on this side. Again, I plug in the negative 2. And I get negative 18 plus 2. That's also negative 16. So because this number balances my equation, when I plug in negative 2, I have the solution. So there is proof that negative 2 is the answer. Okay. So now we're just going through the same procedure. And again, these first two, we're looking at one side of the equal sign. I have parentheses, so I'm going to multiply 8 times x, 8 times negative 6, and then the 58 not involved. And then on this side, I have to do the other distributive property as well. 2 times 4x is 8x, and 2 times 5 is positive 10. So now I look at each side. In this particular one, I do have like terms. On the left side of the equal sign, this negative 48 plus 58, if I bring those together, that side becomes a plus 10, 8x plus 10. Okay. So now I'm ready to switch gears. Each side is simplified as much as I can. So now I'm going to try to get my letters to one side. Again, it is nice to actually take care of the letters first. It usually makes the problem go more smoothly. And in this case, if you do that, you get done very quickly. So this is one of our special situations where our letters have disappeared. So we don't need to continue on with the process because we have no letters. We have to interpret right here. Because 10 is forever equal to 10, this is a true statement. That means that this question has infinite solutions, or all real numbers would be another way to say that, because that's what it means. Every number in the world will work. All right? So that one's nice, short, and sweet because the letters disappeared. Let's see what happens in our next one here. Again, we've got parentheses, so we've got to multiply the 3 times the n, the 3 times the 4. This side, we have no parentheses. Okay, so now we're going to continue to look at each side. All right, this side is simplified as much as it can be. This side, remember here, this n is actually a 1n, so if I combine 4 n's plus this 1 n, that gives me 5 n's. 3n plus 12. All right. So then our gear switches. We're looking at both sides of the equal sign now. I have 3n plus 12 equals 5n minus 5. I'm going to clear one of these letters. It doesn't matter which one. Again, I like to go after the smaller number because that usually keeps me from having to deal with as many negative numbers. Okay, so here my letter's still in there, so we got to keep going. We're going to have to clear a constant. So this minus 5 is our constant. We're going to add 5 to both sides and get 2n equals 17. Now this happens sometimes as well. We are clearing the constant, but the coefficient is next. So in this box, we know that we have to divide to get rid of the 2, and n is equal to 8.5. So you could also write that as 8.5 or 17 over 2. It's good to know all the versions of the answer, all right, by using the division key or your fraction key or your fraction to decimal key. You could get all of those. Okay, again, we're going to check that. This one we can check. This side is 3 and n plus 4. And the other side is 4n plus 5 plus n. So we're going to plug in what we know. This is going to be 3, and then I'm going to use the decimal here, 8.5 plus 4. That's 3 times 12.5. That's going to give me 37.5. Then I'm going to go to this side as well, and I'm going to take 4 times 8.5. I'm going to add 5 to that, or subtract 5 actually, is what the original problem says. I wrote that wrong. That would have caused me to think I have the wrong answer here. So that was a minus 5 in the original problem. And then I have another n in there, so I have to put in another 8.5. 4 times 8.5 is 34. Then 34 minus 5 is 29, and 29 plus 8.5 is 37.5. So those two numbers balance. That means that this is actually the answer to my question. So again, with checking, I'm just taking the original problem, each side. I'm plugging my numbers in using the order of operations and making sure that both sides give me the same value. If not, then that gives me an opportunity to go back and look for my error. Either I made an error when I did the arithmetic here, or I made an error when I solved. Okay. So one more time, we are going to go through the process. Again, here, we have the distributive property. This is something that pops up occasionally. Notice there's a negative sign outside here, the parentheses. So that always means that we're going to distribute or multiply by a -1. So this becomes -1 minus 1n when I multiply by -1. This side stays the same, -n plus 6 minus 8. Okay. So then I'm going to combine like terms. That's always good to simplify each side. And 6 minus 8 is -2, so I have to put a minus sign in there. Now again, on this side, that -n means that's a -1n. Alright, so I have used the distributor property, combine like terms. Now I'm flipping over that line, so I've got to start doing opposite operations. I'm going to try to take care of my letters first. Again, there are different orders you can do this middle part, but this is the method that usually gets you to the answer the fastest and in the easiest way. So if I add 1 in, again, this is one of our special situations. They cancel out on both sides, and I'm left with -2 equals -1, which that's a false statement. That is never true. So the interpretation here is this problem has no solution. That means there's no number in the world that would work. So again, looking at our procedure, distributive property and combine like terms, that happens on one side of the equal sign. Moving letters, clearing the constant, clearing the coefficient, those happen on both sides of the equal sign. All right, so this switch over right here is an important step to the process. Right? We cannot check if we have infinite or no solution. So we just have to rely on our ability to interpret the meaning of those numbers. When the letter disappears, you're going to have infinite solutions or no solution, depending upon what numbers are left. Are they equal? Then they're infinite solutions. If they're not equal, then there's no solution.